for Deloitte Platform Engineering. And my talk today is about durable functions. How many of you have used functions, Azure functions in production yet? Cool, do you like them? So this is about an extension of functions to create serverless stateful workflows on Azure. So these are my details. You can follow me on my blog or on Twitter or on LinkedIn. And this presentation, the slide deck, is going to be on my SlideShare, which is the last link over there. I'm on Microsoft MVP as well. So a bit of the agenda. So first, I'm going to give you a bit of introduction about serverless and functions on Azure, and then I will go deeper into durable functions, what the framework is about, different components, different patterns you can implement on this, and then a bit of a comparison between logic apps and functions. And hopefully we have time to cover 2 demos, which are very similar, but they are different scenarios. Then Q&A, but feel free to ask me at any time during the presentation. How many of you have used logic apps? Yeah, quite a few. So logic apps is a low-code platform for building workflows. And this is how to build workflows on Azure, but with code, just to give you a bit of a context. So this is how we've been deploying applications in the last years. So before the cloud, we were deploying applications on premises. So we would build a web app, and then we would deploy it on IaaS in our servers on premises, or even on a data center. But then with the cloud, the first offering was infrastructure as a service, so we could deploy our web apps or even background services running on virtual machines on the cloud. And then the next wave of evolution was platform as a service, where you just deploy your code, you don't worry about the VMs or patching or anything like that. So more abstraction for that. And the last wave of evolution is serverless. So the key differentiators of serverless is that, don't tell anyone, but there are servers behind. Yeah, there are servers, but they are fully abstracted, so you don't care about those servers. They're fully managed. You only care about building your code and bringing value to the customers. So all the scaling is event-driven, as opposed to resource-driven. So for example, if you have a web app, you say, okay, scale out when my CPU is reaching 80% or my memory is reaching 80%, scale out, or scale down if it's reaching 50%. So this is all event-driven. You don't care about resources or memory or CPU. It's all about events. How many messages I have in the queue, how many HTTP requests I'm having in the backlog, etc. And you only pay for what you use. So if you don't have functions running, you don't pay anything. So functions is one of the serverless offerings on Azure. So in a nutshell, you have triggers, you have some processing or code, and then you have outputs. These triggers will have also inputs. So there are different bindings that will trigger a function. So for example, you can trigger a function, let's say every 5 minutes, or you can trigger a function when you receive a message on Service Bus, when there is a new document on Cosmos DB, when there is a HTTP call by a webhook, when there is a new blog, for example. So you have all these triggers that will create a new instance of your function. And then you have your code. You can write your code in C#, F#, Java, Node.js. And they're working on Python as well, preview and typo there. And then outputs. So you can send your outputs or the end result of your processing. You can send it again to a queue or to a topic on Service Bus. You can send it to blob storage, Cosmos DB, and I'm going to show you how to use SendGrid to send an email as well. You can also send SMS using Twilio. And this list of bindings is growing, and they're open source, so you can write your own extension. There's an extension for SignalR, for example. You can send events to your web application with SignalR as well in real time. Any questions so far regarding functions? It's all clear? Yeah, so you just write a piece of code, you deploy it, you don't need to worry about servers for anything, and then, yeah, let it run. It's quite opinionated because it has some, so you have, the bindings have some parameters, you need to use those bindings. But so the advantage is that you can create your code very easily. So once you start using functions and then you want to start building distributed applications, then you face some challenges. For example, let's say the idea with the function is that you create what they call nano services, so very, very small piece of like single purpose services. And if you deploy in the serverless way in the consumption plan, there is a limit, so they can only run for 10 minutes. But some of your background processes can take more than 10 minutes. So what you could do is break down your piece of work and then say, okay, I'm going to change different functions. So I'm going to run function A, and then function A will put the output in a queue, and then function B will run, right? And then put again the output in a queue, and then function C will run. You can do that. The problem with that is, what if function C fails, right? Then you will need to probably compensate what function B did, right? So the error handling and compensation mechanism can be quite cumbersome if you just functions. Another complexity is, what if you want to, let's say, do some processing in parallel? You want to spin up 50 instances, and then you want to continue after all these 50 instances have finished. So you can create 50 messages in a queue, and then you spin up 50 instances of function. But how do you fan in? So fanning out is quite simple, but how do you fan in? So how do you continue to create a new nanoservice that executes after you have finished those 50 instances? That becomes quite hard to manage. So functions can also be triggered with HTTP, so you can call a function sending an HTTP request, but what if that HTTP request is taking 5 minutes? You don't want to be waiting for 5 minutes. You might be wanting to just call for a status and, okay, let me know when the function has finished. So this is also complex to implement with functions by itself. Again, monitoring long-running processes. What if you want to have human interaction? So let's say you have a workflow where a person has to approve something or has to give some inputs, and you want to time out of a certain period or do some escalation process. So with functions, without this extension, is quite hard. What if you want to correlate multiple external events that you're getting? Let's say you're getting events from GitHub by webhooks, and you want to correlate those events. So without this extension, is quite challenging. Then enter durable functions. So durable functions allow you to implement function chaining. So you can implement this, okay, execute function A, and then function B, and then function C. But then you can implement also error handling. So if function C fails, you can do some compensation, or you can do even some advanced retries. So let's say function C fails, retry for 5 times with exponential backoff and all that. So all this logic you can implement with durable functions. You can also implement fanning out and fanning in very easily. We will see this in the demo. You can also call trigger a long-running HTTP API and then call for the status, which is also useful for monitoring. You can implement human interaction as well, and you can also correlate external events. So all these patterns are documented in the documentation. The last one, they mention it as a challenge, but it's not documented. But there are a couple of blog posts that explain how to use the external event correlation. Any questions so far? All clear? Very easy. So durable functions is an extension of functions. So it's just an extension. You can even look at the source code. It's open source. It's based on durable task framework. And what they do is they use a storage account. So all the messages between the functions is using storage queues. And so I'm going to show you, but every step in the orchestration is being checkpoint. So they use what they call event sourcing. So this event sourcing is stored in the stable storage. We're going to see that in the demo. And then you use code to implement this workflow. So you can use C# or F# or Java, Node.js, and they're working on Python support as well. Okay, so these are the components. So these are the different components that are part of durable functions. So first you have the orchestrator. Right? So this is the orchestrator function. So this is where you control the state of your workflow. It implements a process manager pattern. And this orchestrator is in charge of calling different functions. So it can be just implementing your sequence of functions. You can implement fanning out or fanning in, all those patterns that we mentioned before. You can have advanced retries, like as I mentioned, retry 5 times, implement exponential backoff between the retries, etc. You can implement fallback operations or compensations. So let's say you try to call function A, but function A doesn't respond. Then you can say, okay, let's try with function B. Function B can be a fallback operation as well. So if function A is executing as an activity function, then you don't need to pay for the orchestrator. So let's say you have human approval process. So while you're waiting, you don't need to pay for that waiting period. So because the orchestration kinds of dehydrates on storage, so you're not paying for that time, that idle time. Yeah, and all the communication, as I mentioned, is using messages on storage queues. We're going to see that in the demo as well. So the orchestrator function is the main process manager, which is all code. We're going to see that in the demo. And then we have the activity functions. So the orchestrator is kind of stateful because it uses this event sourcing with storage accounts, but activity functions are stateless. So they don't know anything about the workflow. They just execute one single step. And then all the inputs and outputs are using, again, messages on storage queues. So it's very important that your inputs and outputs are serializable because your object gets serialized into JSON, puts into a message into the storage queue, and then this is how you communicate between the orchestrator and the function. And the really good thing about this is fully abstracted. So you just call a function. You don't know that there's a message behind the scenes. You don't know that there's a storage behind the scenes. So it's fully abstracted for you. And then you have the client. So the client is the one that starts an orchestrator. So let's say you want to create a new instance of a workflow. You use the client. You can also get status. You can also send events, external events. We're going to see all that. And you can even terminate an instance. Let's say you don't want the instance to continue running. You can terminate it using the client, all with code. Yeah. So there are some limitations or constraints, but there are workarounds. So the orchestrator code has to be deterministic, so we're going to see this in the demo. So the orchestration every time. So let's say when you're calling function, let's say function A, B, and C. When you call function A, so this is the first line of code. Then when you receive the response, the orchestrator starts from the top. Yes, and then executes again, and then checks, is function A being executed? Yes, it gets from the event sourcing store, and then skip that step, and then goes to the function B. But the whole orchestration is being executed every time it receives a message. So because of that, the orchestrator has to be deterministic. So you cannot have any code that is non-deterministic, like generating random numbers or GUIDs or doing any I/O. So if you're doing that, you have to do it in the activity function. It has to be non-blocking. You need to use the context to initiate any asynchronous calls, and you need to avoid infinite loops because you're writing to the event sourcing store. So you have a massive number of events, then the orchestrator will become very, very slow. But there are workarounds for all of this. So these are limitations. You cannot use the orchestrator function for doing this, but you can always use activity functions to implement these operations. I think I mentioned most of these. Yeah, those text. Cool. Any questions so far? Yeah? Are you sleepy or? Is it very dense? A lot of information? Cool. So to implement the chain, so this is to call function 1, 2, and 3. This is very simple, as you can see. So you're using a context. So this context is so you're using a binding in the function. So you have a context, and you use this context to call the activity functions. You say call this activity function, and you pass your serializable input, and then you would get a serializable output over there. So as you can see, I'm calling 3 functions here. It's just 3 lines of code, and everything is abstracted. So there are queues in the background. There is a storage account taking all the event sourcing and all that. But it's just 3 lines of code, very, very simple. And then you can implement your error handling here. Yeah. So this is just to implement chaining. And again, we have some bindings. So we have the orchestration trigger binding. So this is the orchestration function. So the client will have a different binding. The activity function will have a different binding. We're going to see that in the demo. So this is to implement the finding out and finding in. So in this case, what I'm doing is implementing a for each loop, or a for loop, right? And all these activities are being called asynchronously. And then I'm using task. So I'm using task when all, and then when all tasks have finished, then I will continue. Right? And this orchestrator again, so the activities will be running in the background, and then this orchestrator will be dehydrated, and then when all the tasks are completed, then it will become rehydrated, and then it will continue. Yeah. So as you can see, the code is very clean, very straightforward, but there is a lot of logic or smarts happening in the background. Yeah. And this is the client. So the client has a different binding. So you say, yeah, this is a client, and you have the client. I'm calling it Starter because I'm using it to start the orchestrator, and then I use the Starter to create a new orchestrator. So I start new async with the orchestrator name, and I pass the input for the orchestrator. Very straightforward. So I'm going to show all this in the demo, just to give you, this is a simplified version of the code. So I mean, very clean. The demo has more logic.
So we need to use attributes orchestration client.
Yes.
And they are.
Yeah. So all the functions extensions are bindings, right? And then they have this opinionated model. So then, so in this case, we're using the orchestration client to initiate an orchestrator, right? This is a trigger. So this, for example, is an HTTP trigger function. So it receives an HTTP request, and then with that request, that's going to be the input for the orchestrator. In my demo, I'm going to show you, it's going to be a blob trigger. So a blob will trigger the function, and this blob will be passed into the orchestrator. Yeah. Any other questions? Is it too easy, too hard, too dense? Cool. Okay, just to give you a comparison between durable functions and logic apps. So as I mentioned, both are serverless, and Microsoft is promoting both, but there are some differences. So if you like code, if you like C# or Python, then you would go with durable functions. But if you want low code or just workflows and drag and drop, then functions would be a best fit for purpose. Another difference is binding. So Logic Apps at the moment has 250 plus connectors, so you can connect to Dynamics, to even IBM mainframes. I mean, you name it. It's really this list is growing and growing. And for functions, you only have like 20 odd bindings. So the connectivity is quite limited with functions. At the same time, the runtime for functions is portable. So I'm going to show you, I'm going to debug the functions on my local machine. You can deploy the runtime on AWS or on GCP, whatever. You can run functions wherever you want, on containers as well. Whereas Logic Apps, at the moment, they only run on Azure. They have mentioned that they're working on container version, but yeah, I don't know when it's going to happen. So Logic Apps, they have very rich monitoring and management tools, whereas durable functions is just based on app insights and API, so it's quite limited. And then both have serverless option where you only pay for what you use, but they also have dedicated. So you can implement durable functions in app service environment, and now they're working on a premium offering where you always have at least one instance, so that's going to be dedicated for you. And Logic Apps have what they call the integration service environment, which is quite pricey. So depending on the use case, you would use one or the other. So both implement workflows, both are serverless, but one is more towards coding. So if you have a very complex workflow that you don't want to deal with visual designers, then probably durable function would be a better fit for purpose. But if your workflows are not too complex and you want to leverage all the connectors and all the management and monitoring tools, then Logic Apps would be better. Yep. Cool. So additional resources. So you can follow the functions team on Twitter. You can read the documentation. They also have live webcasts, kind of every month or every second month. You can check their repos where you can see all the code. There are samples about durable functions, and then there's a Pluralsight course as well from Mark. He's very good, and his course is very, very good for durable functions. Any questions before we move into the demo? Yep.
Can you please share your thoughts about performance comparison between different functions? there any one better than other in terms of performance?
It's a very good question. So these are for asynchronous processes. So I would never recommend logic apps or durable functions for high throughput. So if you want to have, for example, an HTTP endpoint, unless it's very simple, I would not recommend this because you are using queues in the middle, right? So you're using queues. Even logic apps, there are queues in the middle. There are workers, what they call competing consumers. There are workers reading these messages. So I would never recommend this for super high throughput APIs. But if you are planning to use just processing in the background, it really depends. So I would say C# is more performant, but then you need to tweak it. So because the function will run every time from the top, you can say keep this orchestrator in memory for, let's say, for 30 seconds or 1 minute. So you can keep it in memory. So whenever you receive the message, you don't need to rehydrate the process. So there are tweaks that you can implement. So functions, I would say, is a bit more performant, but you need to tune it for that. Yeah, cool.
I think a few reasons that could be used for choosing the functions or logic apps would be being able to compile the code and do error checking at compile time with the functions versus logic apps. And unit testing, you can't do unit testing with logic apps.
Yeah.
Those kind of things. So if you have automation and all that in your deployments, then function apps would be more preferable.
Yeah, that's a very good point. They are working on providing testability on logic apps. I don't know when that's going to happen, but they are working on that. So in the future, that's not going to be the case anymore. But still, you need to work on the cloud. With functions, you can test locally. So logic apps, you would be able to automate your testing, but you would still need to run it on the cloud. So they're working on testability, but still, it's going to be on the cloud. So if you're running this, if you're automating this, you would need to still connect to the cloud and see what's happening on the cloud.
I think they are releasing a preview of mocking feature, something like that.
Yeah, the mock.
Logic apps?
Yes, the mock. So they have, for every action you can say, return this mock response. So that's already in place. They're improving that. So they're making it more extensible. At the moment, I think you can only get one static. They're working on making it to cover different scenarios in one workflow. And at the moment, when you're developing, you say, I want this to use the mock, and that's it. But this is at development time. So what they're working is at runtime for testing. They're like, okay, this workflow, I want to test it. So they haven't disclosed yet how they're going to do it, but they're going to allow you to automate this from your release pipeline. At the moment, it's just at development time. You have a very good points. Any other questions or comments? Yep.
Seems like it makes a very good use of task-parallel library with the context being moved around from one function to another. Do you see any call samples on how it works with JavaScript or Python, where obviously task-parallel library doesn't exist there?
So I haven't used those codes, but so they're using the durable task, and this framework they are migrating it to Java and Python. So they're working on that. So it's fully supported. I haven't worked with those.
Just keep in mind, can you call these functions from the logic app and the other?
Yes, you can mix and match. Yeah. Good point. You can mix and match. So let's say you have a very complex workflow, and then logic apps might be a bit limited, but you can use very complex workflow on your functions, and then by HTTP or via messages via service bus, you can call logic apps to make use of the connectors, for example, or the other way around. You can have your master workflow on logic apps and then call small functions or durable functions. Yeah, you can mix and match definitely. Any other questions, comments?
Have you seen any cases where they replace index workflows with Azure logic apps or durable functions beside the forms? Can we use it in Office 365 instead of Nintex?
Haven't seen any company replacing, but I have seen many companies saying, yeah, I'm going to explore this instead of going with a different vendor, because they want to have just one. So the less vendors for them, the better, right? So with Flow and Logic Apps, you can automate these workflows with SharePoint and all that. Yeah. So I'm not an expert in pricing, but it has been changing. They charge you per execution time in functions, but it's very, very cheap, and they give you so many minutes or hours for free. So if you have a subscription, you already have so many hours for free per month, and then after that they start charging you. It's really, really cheap. So Logic Apps is a bit more expensive because they charge you per action. So if you have a lot of executions and then you're very price sensitive, probably your function would be a bit cheaper. But yeah, Logic Apps gives you more functionality as well. It's really, really cheap, really, really cheap. Especially with this, because when the orchestrator is running, it's idle waiting. You don't pay. You only pay for the activity functions. You might reach a point where, let's say, your functions are running 50% of the time, and you might as well deploy it in an app service dedicated instance, because you might be paying more for the serverless option. So these functions you can deploy on an instance. They are not serverless anymore, because now you're paying for the instance regardless of being idle or not. But you might reach a limit where you're saying, yeah, probably I might pay in advance my dedicated instance or a couple of instances.
Does it have the same cold start like the normal?
Yeah. So there is cold starts and all that. So let's say let's say there is an HTTP trigger, so the HTTP trigger would have the same cold start. So cold start is because in the serverless, if you don't use the function for, let's say, 20 minutes, they will decommission that image. So then when you call that HTTP endpoint again, they need to get that image from their store, spinning it up and then warming up, and then they would respond to your request. So it might take a couple of seconds to respond. So yeah, there's always functions behind the scenes on this. Cool, I'm gonna continue with the demo, and then we can have more Q&A at the end. Cool. Okay. So the demo is for a company called Furry Models. So this is a real company. They have models, so they have cat models, and they wanted to implement an approval. So there are cats running the company. So they hired me to implement this workflow, and then say, yep, they want to go with serverless because they know it's the future, so they don't want to pay for an expensive workflow or anything like that. They said, I want to do everything by a serverless. And the cat managers, they wanted to automate the approvals because they're getting very popular. So they were getting a lot of requests from different cats, and they were saying, yep, I want to be able to approve the request via email. So this is the workflow we implemented for them. So there is a mobile app for the cats, and they submit their picture, and then this mobile app is dropping the picture in a blob container. So this will trigger the orchestrator, and then it will send an email to one of the approvers saying, do you approve this cat? Do you think this cat is handsome enough or sexy enough or whatever? And then there is a timer, because so sometimes the cats are very, very, very busy. So if after, let's say, I think at the moment it's 5 or 10 minutes, if after 5 minutes they don't approve it, then it will be rejected because they are so busy. So here we are doing some kind of finding out. So it's waiting for the external event from the email, but also there is a timer. And then instead of when all, we have a task.whenAny saying when any of these reaches, when we receive either the approval or the rejection or the timer expires, then we continue with the workflow. And then once we approve or rejected this cat, we need to move the blob from one container to a different one. Yeah. And then this is just to show you. So this is the orchestrator function. And then we have the client. So the client is triggered by a blob. And this is the one calling the orchestrator. And then we have activity functions. So I simplified a bit the workflow just to make it very simple to follow. There's a couple of more activity functions, but there is one function that sends an email using SendGrid. And then SendGrid has a link that will call the client to send either the approval or rejection. And then will continue, and then there's another activity function that moves the blob to the corresponding container, and then we can even check the status. So the cat can say, can I check how's my application going? All clear? Yep. Cool. Okay, so I have, this is the Storage Explorer. So this is where, so I'm using the free version of SendGrid, so hopefully it behaves today during the demo. So let's assume that this cat submitted their app through the mobile app. Or is it running? So this is the durable functions running on my machine, but is polling the blob on the cloud, right? So this is the functions running locally, which you cannot do on Logic Apps. Here you can do because I have the runtime here, and this is monitoring the blob on the cloud. So hopefully it will react to this event. Otherwise, we can put a different one. So what I'm simulating here is that this mobile app putting the blob here in the request folder. Yeah. So now this is the orchestration client, right? And this is, can you see okay? At the back, yeah. And then it's triggered by a blob, right? So this is happening in real time. So I have a breakpoint here. So it's reacting to the blob that I just put in the container. And then what I'm gonna do here, this is just some logic to identify the email of the cat and all that. But what I'm doing here is just creating a new orchestrator with this name, and I'm sending the request metadata. I'm gonna run it all the way. And this request metadata will have the blob URI. Yep, so this is the blob URI that I'm sending to the orchestrator. So I'm just preparing, so again, you can only send one message per request. So I'm sending all this data in a serializable object, which is this. I'm also getting the email from the cat, which is written by the mobile app, and then sending it to the orchestrator. I'm gonna continue. And now this will trigger the orchestrator function. So everything is happening behind the scenes. So this put a message into storage queue, and then now the orchestrator is reacting to that message in the storage queue. Everything happening in the background. I didn't have to worry about any of those queues or messages. So now this is the orchestrator. So we have the orchestrator context. And what I do here, so I'm getting the means of approval, which is email for this case. And then this is an activity function that I call to persist the correlation between the email and the instance ID. I'm going to show that later. I'm setting the status. So whenever they can check, the cat can check in the mobile app what's the status of the application. So I'm saying if we are at this point in time, then we're going to tell them we're reviewing your application, bear with us. And then this is where I send the email using this function. So I'm gonna let it run. Should hit this breakpoint, and then I think there's a breakpoint on the email as well. I think otherwise, the email is just, I think probably there is no breakpoint over there, but I'm gonna show you, we have it here, the code for the email. Well, I'll show it to you later, but I should be getting, cool. So 12:04, we're getting this from the, yeah. So now you send grid. So now this is the approver, the cat approver would get this email saying, do you think this cat from this email deserves to be part of the agency? They are a very exclusive agency. So what do you think? Approve or reject? Approve? Okay, approve. You like the mustache. So approve. So this will trigger a a client. So this is a client function that will continue with the orchestrator. This is HTTP trigger. Yeah. And then we just get some metadata. And then at the end, what we do is we raise an event saying is approved. Well, I need to run it, but we will run. It will raise an event, and then we will return. So in this case, it was approved, right? So this will raise an event to the orchestrator, and then it will return a message, thanks for your selection, to the client. So let it continue. So this is the message should be getting once it finishes. So it's still debugging. I'm going to let it run. So this will call. So we are updating the metadata for the status, and then what we're going to do at the end is we call activity saying move blob to the corresponding folder. So if we check here, some seconds. Yep. So it's not in the request. Shouldn't be in the rejected. Should be in the approved. So not rejected. Now if we check in the approved container, it's here, right? So now the workflow moved the container from requests to approved. Yep. Any questions? So I'm going to show you the activity function that sends the email. So this is very simple. So this is using the SendGrid binding. So this is one of the bindings you have. So SendGrid is a service where you can use to send emails. And I'm just saying, yeah, this is the from, this is a to, and then send. So I have an HTML already in my config. I'm just passing the values and then sending the. So because there is an output here, the output is a SendGrid. So when the function finishes, it will send that email. Yep. So we can. Let's move to the next demo because hopefully it's a bit more fun. It's very similar, but in this case, the next demo. Or do you have any questions for the code before we move into the next demo?
Containers have anything to do with?
No, it's a bit misleading. But in Blob, what they call containers is just like folders. They call it container. That's the name, but it doesn't have nothing related to Docker or anything like that, or Rocket. Yeah, it's just Blob container. Yeah, not as fancy. Any other questions?
Blob trigger, does it work by sending an event through event grid, or how?
At the moment, I have the code for both, but I'm using just the blob trigger. Yeah, but you could always create an event grid event and then react to that. So I prepared the code for both, but I'm using just the blob trigger. It's a bit simpler to show. It's polling the log of the blob. Yeah. Mm-hmm. Cool. Yeah.
What guidance would you give for splitting this workflow into multiple steps? It's very easy to fall into the trap of putting multiple steps into one function, or over-engineering it and splitting every small thing into its own function. What guidance do you normally use in splitting these into smaller functions?
Well, every developer would think different, I think, but you need to follow like single purpose, right? And then, so the function has to be single purpose and also maintainability. So you don't want to have one line of code per function, right? So yeah, I think the main principle is single responsibility. So each function has to be just one responsibility. Yeah. Cool. Any other questions?
How are you managing state between functions?
So the state between functions, I'm going to show you something very quick. I'm going to do another run. So I'm going to now let's pass this one. So request. So this should trigger a new one, a new instance. Yep, so then now we have, this is still from the previous one. Okay, so this is the blob, right? And then this should send an email again. So I'm gonna stop the function, right? And then run it again. So I'm killing the process completely, right? And then running it again. And it will get it, because the thing is, if the message is still in the queue, so it really depends on the state. So if there is a message that is triggering the function and the function dies, the message is still there. And then you also have event sourcing. So if hopefully so this is gone.
Careful with debugging.
Yeah, well, yeah, and then I'm also dealing with I shouldn't have killed it at that time. I should have killed it.
That's what I'm saying.
So yeah, probably the timing for that killing the function was not great, because I'm debugging locally, right? So that's not the expected behavior it's deployed. But yeah, coming back to your question, so you have two sources of state. So one is the queues. So between the orchestrator and the activity functions, you have queues. So if the queue hasn't succeeded, then the message should remain on the queue. But also, if the activity function takes very long to complete, and then you continue with, let's say it completes, then you always have the event sourcing. So you will have this activity has finished, this activity has finished, this activity has finished, and then let's say the fourth one hasn't finished. Then when you get that message, the orchestrator will know that the first three have finished, because it's all in the event sourcing table. So there you have these two, event sourcing and in queues. Yeah. Cool. Okay, so next demo is very similar scenario, but now we're gonna let your cat apply. So hopefully that goes well, because now we are relying on logic apps as well. So now what we're gonna do is the same workflow, but now we're gonna use Slack instead of email. So here for this demo you can participate. Hopefully it behaves okay. So send an email to this email address, and then attach your cat. And then just make sure that you add this subject, I want to be a furry model. And then we should be getting these applications on Slack. And please keep it for general audience, because this is being recorded and broadcasted by YouTube, so many kids would be watching this. So just don't put any.
You're giving us ideas now.
Well, you can put some bikini cats or something like that, but. So hopefully that goes. So I'm relying on logic apps to receive the emails and calling the emails, because there is connectors for emails. So that bit, getting from the email into the blob, is relying on logic apps. I can show you the logic app if you want it. So that bit is not fully tested, so hopefully that behaves okay. But then once the image is on blob, then everything else is observable functions. So we should be getting some requests coming soon, I believe. Well, if you're allowing your cat to submit an application. Okay, so the logic app is polling my email. So I'm gonna just make sure that it's running. Have you sent your emails yet?
Yeah, I got applied.
Okay, cool. Cool, so we started receiving some. Hopefully, okay. Oh, this is the previous one, the one that I killed. So I'm gonna kill this one because now we are receiving. So this is running on the cloud.
Are you rejecting my cat?
No. So again, this is Logic Apps. This is from Haas, but so didn't go through. So there was something. Did you put the subject and everything? Our subject has to contain furry in the subject. Yeah.
Tell me that.
Yeah, it was part of the instructions. So it has to contain furry. So I want to be a furry model in subject. So it's got a cat. No cats? No cat people here? No? So no one has a cat. Okay, so some submissions coming through. Okay, so now we have messages in Slack. So now, wow, cool. Okay, so this is, as you can see, instead of using the SendGrid, now we are using the API's connectivity with Slack. Right? So we're sending this to Slack. So then there's a cat called Graham, apparently, the principal cat. Okay, so let's approve this one because Xelo is sponsoring the event, so we need to approve this cat, of course. And then, what do you think about this one? Approve or reject?
Yes.
Yeah, approve. Okay, so Surya, we approve the cut from Surya. So we have. Okay, so let's check, for example, this one. So from Ian. So now we can check. Remember, I told you that we can check the status of an application, right? So let's go here. So now we're running the functions that are deployed on Azure, so it's not running locally. So I'm gonna say I want to check the status for this applicant. And I get this. So we can make it a bit more friendly, but I'm just showing you this just to give you an idea of. So you can check the status, and the status is we are reviewing your application. Bear with us. So let's now approve this one from Ian. Nice cut. So I'm approving this one, and then let's refresh this one. It'll take some time. Is that the first one you approved? Congrats, you're super special. Yep. So we can check the status for an orchestrator. Yep. Well, this is scary. Reject. Sorry, Valerio. This is very scary. So again, if we check the status for this one, we rejected, sorry, only the best can join us. So all the states and everything is being managed by the durable functions framework. Yep. So this, what we are doing here is this is sending. When I click request approve or reject here, we have a handler. This one. So the one that sends the request via Slack, what it does is there is a URL, there is an endpoint listening to these requests, and what I do is just an HTTP. This is about practice, by the way. You shouldn't be using HTTP client like this, but yeah, just for demo purposes, I'm using it and destroying it at the end. But then, so we create the content using so there is a so if you want to create buttons, you just need to follow a JSON format, and you send it. So you send it, you post it, and then you receive a response saying this is an HTTP OK, saying yep, it's posted. So this is to send the request, and then to get the response, what I'm doing is, so I receive form data, and then I can get the instance ID from the request, or from the approval, sorry, and then I get the from and the name from the different parts of there's a correlation token I can use, and then I get the status of the orchestrator, right? And then the orchestrator has to be either running or pending. If it's not in any of these two, then I send a response. Let's say, because there is a timeout, right? So let's say the timeout expires, or it's already 5 minutes or 10 minutes or whatever the limit is. Then if I click approve, then I need to allow the client say, no, this is already expired. So I need to check that it's running or pending. If it's not running or pending, then I return saying the approval for this application has expired. And I'm using the emoticons of Slack here. But if it's okay, then I just send thanks for your selection. So this is what I'm displaying here. Thanks for your selection for this has been approved. Cool. Any questions?
Some unrelated question. These buttons approve and check the Slack feature, and
yeah,
and it also a reply with JSON, which
yes,
which button.
Yes. So good question. So the Slack API allows you to send JSON to create buttons. So this should be part of my local settings. So this is the HTML for my SendGrid email. This is the template, right? And then for Slack, I have this JSON template, and then I just I use some placeholders. These placeholders here, where I'm sending some data. Everything else just a JSON. Yeah. So you create an app on Slack saying I want to receive messages, and then you say these messages I receive on this app, post it on this channel. So you give the channel, in this case my CAD model approval channel or CAD model agency channel. So everything that I receive on this HTTP endpoint, post it here. And then if I follow this JSON template, then it will render the buttons over there. And then each button will call another endpoint. And so what I do is there is a correlation token. I pass all this information in the correlation token saying this is the workflow ID, and then when they approve, this approve action will send that correlation token back to my HTTP endpoint, and then this is how I can correlate this. Yeah. Any other questions?
So, what's the retention period for these events that are logged in the backend?
You mean on the durable functions? Yeah. As long as you don't delete the function and the storage account, they will live forever.
So, do we need to provision a storage account for that, or?
Yes. Yeah, you need to have a storage account. So you really don't need to know all these details, but so there are these, for example, these lists, and then you have everything related to workflow Hub V1. This is the one I'm using at the moment. So we have instances, we have history. So history, I think, so this is where all the event sourcing is managed, and then we have queues as well for that workflow V2. See, so all these queues. So as long as you don't destroy that storage account or don't undeploy, even if you undeploy this function now, but you keep the storage account, and then you keep the same. So this is important. So when you're saying here, is it in this one or is it in the host? You give a name to the hub. Yeah, so this is the hub I'm going to use, for example. Then you can deploy a new function app. You can say now use this different hub, and then you can have side by side different versions of of workflow. So this is, so if you are changing the contract of your develop function, so let's say you add an activity or you add parameters to your activity or you change the object of an activity function. If you want to have them, if you want to run them side by side, the best way to do it is create a new hub, and then you can have deployed in different deployment slots, for example, or just different function for different versions.
Are we not charged for all these events that are stored in the storage?
Yeah, you're charged, but it's very little really.
So if you break the plugin and there are some outstanding queues, can you just delete it on the storage? How you clean up this queue or these tables?
Let's say you messed up with the environment. Yeah, you just remove the storage account, recreate. That's it. Or another option is, let's say you messed up with some of the data, but you still have some running instances you want to finish. Then you can create a new hub, and then it will create automatically new queues, new tables. Yeah, everything. So everything is abstracted. Just rename this, redeploy. Next time it runs, it will create new queues, new tables, and all that. Mm-hmm. Any other questions? No? All good? Okay. Hope you enjoyed the talk. Let me see if I don't think I have anything else on my slides. So yeah, so the source code of this demo is on this GitHub repo. You can have a look there, and then I had 2 blog posts that explain more or less how I build this, so that you can also have a look at the blog post and see what's in there. But yeah, otherwise, I think there are no more questions. Thank you so much. So again, these are my contact details. So if you want to reach me, you can send me a message on LinkedIn or Twitter. You can also follow me on my blog. Cool. Thank you so much, guys.